Shared values algorithm question. Let's imagine that we're to create a function called shared values, where we're given two parameters, both of which being strings. And for this function, our goal or purpose is to try and find every character that is shared between these two strings and count the number of instances that this character is shared. Now, what do I mean by the number of instances that these are shared? Because that's a little bit of a mouthful and quite convoluted, right? Well, if we look at example 1, the first string only has one A, whereas the second string has 2, right? And so if we're going to be making a pair where we say it's truly shared between these two elements, then we can say, well, these two are a pair, but what happens to this one, right? Because this one's now eliminated for string 1. String 2, not so much, right? There's no other A that it can go to, and so it's just kind of a free floater. And so when we go to the output then, it should just be A equals 1, where its value for the key should be 1, despite the second string having 2 occurrences of it. And the same is true of the B, where there's one B here, but there are 2 here. And so these two become paired, but what happens to this guy? Well, nothing. He doesn't have a pairing. And so the result then, or whatever output this function will give us, is just one instance of B and one instance of A, which is shared between these two strings. And this pattern repeats itself when we look at example 2, where, well, the first string has 2 B's, 1, 2, right? But the second string only has 1. And so these two get matched, but this lonely guy has no pairing. And this process, well, will repeat with whatever 2 strings that you're given, right? And this will output something along the lines of, there's one pairing for B, there's one pairing for R, despite librarian having 2 of them, and there are 2 instances for A between these 2 strings. So luckily for these 2, they're not, none of them are lonely in the case of A, right? And so how do we implement this function then? Well, what we can do is create a dictionary, right? Where we iterate over one of these 2 strings, it doesn't really matter which one, and we say, well, for every character that we've looked at, hasn't it shown up yet? If it hasn't, then add it into this dictionary, right? And so for the first iteration, well, we go from having checked nothing, hence there being an empty dictionary, to having checked A. And we say, well, A isn't in this dictionary yet, and so we can add it in there. And because now we've seen at least one A, we can pair it with a value 1, just saying, hey, we've seen this value, right? And then we move on to the next character. And now we've seen that, and we've seen C, and so on and so forth until we get to F. But ABBA is probably a little bit more interesting, where we have 2 characters, but we'll get to that in a minute. And so if this string was slightly different, because we wanted to look at what repeating characters looks like, right? Let's say there's another A here, and another one, and another one, right? Well, for every instance that we see it, it would go, well, we're going to want to increment this value. So 1 plus 1, and then we want to increment it again. So let's say a plus another 1, and so on and so forth until this equals 4 in accordance with the number of occurrences, right? But if we're going to want to compare this string with this string, then maybe instead of just recording one value, maybe instead we can make it a key value pair with an array, where the array contains two values, one being the number of occurrences where A appears in the first string, and the second being the number of occurrences where we've seen it in the second string. And we're going to initialize it to 0 because, well, we haven't looked at the second string yet. So how would we know, right? And so if we go through this iteration with this kind of logic, well, we can just say B is going to be 0, and C is going to be 1 and 0 because, well, this is the first occurrence that we've seen it in the first array. And we've seen 0 occurrences of this because we haven't looked at the second array yet. And so on and so forth until we get to A, again, over here, right? And once we get to that point, we go, well, we've already seen it, and if we've seen it, that means that this number here should be in accordance with the number of instances that we've come across that character in set string, right? And so since we've got into this point again, well, then in the same vein as here, we would increment it, right? And do that again, and again, until there are no more instances where A appears in the string. And once we've done that, what essentially winds up happening is this dictionary will have every single character that appears in the first string. And it'll also have the number of occurrences that character appeared. Because, well, with a for loop, it's going to iterate over every single character. Unless you wind up making some kind of if statement that makes it skip or terminate early, right? And so now that we've iterated over this first string, what do we do after that, right? Well, our goal was to compare these two strings, so why not iterate over this one, right? And so we look at ABBA and we say, well, the first iteration is A, and because we're in the second string, we're going to be looking over here. And so right now we have 4 occurrences in the first string because it went 1, 2, 3, 4, right? And now that we've come across one instance of A in the second string, it now gets initialized to 1. And the same thing for B, where B occurs once in the first string, and so we put 1. And now we finally come across B in the second string, and so we initialize that one to 1 as well. And then we come across it a second time, and so it winds up incrementing. And same with A, where it goes 4 and 2, right? Or it might be a bit more clear if I go with equals, 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 and equals. I'm sorry for the poor writing, but now that we've compared these two, we're going to want to return out a string that kind of looks like A, B, right? And so how do we do that? Well, what we can do is currently this dictionary has every single character in this first string, and we don't really want that, right? Because F has 0 occurrences where it's shared between these two. It doesn't ever show up in the second string. And so instead of that, let's make a new dictionary, right? And this new dictionary, we're just gonna base it off of the two values in here, where we say, okay, let's take the exact same key, iterate over every single element in this dictionary, like all of the dot items, and then take the minimum value of the values of the key and store that as a new key, or a new value, sorry. And so how does that look? Because again, this wording is a little bit convoluted, right? Well, let's take this A as an example. Right now in the dot items, it's going to iterate over itself until it gets to the A, right, as a key. And it's going to take the values that's stored in here. So there's 4 and 2. And what we're doing here is we're saying, well, let's take the minimum value between these two, right? And whichever one is smaller, that's going to be assigned to A in this new dictionary. And once we've done that, well, so long as we're ignoring the zeros, and then what will eventually happen is we'll get every single key where they're shared, but because we're taking the minimum value, it's going to be the exact number that can be paired between these two. And by that point, this algorithm is basically finished, right? We can just return this dictionary, not that one, this dictionary, and then if we want to print the results, it'll give us, or it should give us, what's ever in here. And yeah, that's how you solve the shared values problem, loosely speaking. Thanks for listening. So how exactly did we go about actually answering this question using actual code, not just pseudocode? Right, well, on 6 and line 8, you can see that the parameters are the same as the ones that I had written out earlier. And so what we can do is, well, with the exact same logic as we came across earlier, we can create a dictionary. For 1, to match the output, and 2, just because hash maps are very, very well optimized in terms of runtime, right? And so once again, we are going to be comparing the characters between these two strings, and so we might as well iterate over one of them, right? And so whichever one we iterate over first doesn't really matter that much, but for the sake of simplicity, let's start with iteration 1. So for char in iter 1, and we're going to say, well, if you haven't come across that letter yet, then it shouldn't be in word, because word dict is comprised of letters that we've seen, right? And so if char not in word dict, then now we've seen it, and so we should add it. Word with char. And again, we could assign it to 1, but we want to keep track of the number of occurrences that this character has appeared in both arrays, so why not, or both strings, and so why not just make an array out of it, right? Let's say 1, because we've come across it in the first string, and then 0, because we haven't come across it yet, because we haven't looked at the second string yet. And now, if we wind up doing an else condition, because we should have an else condition, what would that else condition be? Well, it would be that the char is inverted, right? And if it's inverted, that means we've already come across it. And if we've already come across it, that means that the value is either 1 or greater than 1. Or it should be otherwise. Our logic is very, very wrong. Somewhere we've gone absolutely wrong. But in any case, in that case, we can just say, well, the 0th indices of this array, that being right here, let's just increment it by 1. And to say, well, we've seen another instance of this character in the first array. Let's record that. And that's exactly what line 7 is doing right now, right? And so once we've gone over all of the characters in this array, what do we do then? Well, again, we're going to have to compare it to the second string sooner or later, so why not now? So for char in order 2, if the character or char is inverted, oops, then let's increment the second indices, or the second position, that being here, which was the counter for however many times we've seen that character in the second string, and now that we're finally in the second string, we can finally increment it. Plus 1, right? And we don't need to do this if not char, if character not in word dig, because since we're looking for shared values, if it's not a character that appears in the first string, then it's a character that, quite frankly, we don't care about because it's not going to pair, right? And so now that we've done that, we can just come out of that for loop. And now that we're out of that, well, now that this for dig is comprised of every single character that's in this first array, right? Even the ones that, quite frankly, we don't care about, like C, D, E, F, more than half of this string. And so what do we do then? Well, again, we can create a brand new dictionary and just say, we'll use the exact same key, but for the value, we want the lowest one between these two. Because the lowest one is going to be the maximum number of occurrences where these two numbers are shared. And I know it's a little bit confusing in terms of that wording, but we're going to be using the min function. But again, think about it really quickly, right? If we have not a wait, and A, then the shared subset between these two is A and A, right? This guy, unfortunately, doesn't have bearing. And so, even though this is the maximum number that is shared between them, it's the minimum number of occurrences of A between these two arrays. And so, now that we have that covered, all we have to do is say, well, value 0, not 90, and value 1 is going to be the pairing for whatever key that we're at. And what is key and what is value? As the terminal is currently asking us, since we haven't defined it yet. Well, those are going to be the different key value pairs that are in word dict, and to get those we're going to have to iterate over those key value pairs that are stored. And so we're going to for loop it, and we've already established that it's going to be a key and it's going to be a value. And so key value. Now Visual Studio is complaining a lot less, thankfully, in word dict. But word dict is a dictionary, so it's not easily iterable, right? And so instead of just typing word dict, let's go to items, because dot items makes it so that it becomes an iterable. And we've already established that, well, we're going to have a couple of letters or characters in the word dict that might appear once, or even more than that, maybe like 10, 20 times, but never appear in the second array, in which case, or second string, in which case, well, the second value, this value that is stored in the first indices or zeroth indices, wherever it's 0, equal to 0, is always going to be the min value, and we don't want to store that. And so let's say if a value uh, 0 is greater than 0, and value 1 is greater than 0. And so that we don't start putting in characters that aren't shared into this dictionary, right? And once that's done, we just return shared dict, and we should be done. And so let's see if this matches. 1, 1, 1, 2, 1. Yay! And that is the shared values algorithm problem.